Hey, this is Step Amit. Welcome to my Exorcism.io walkthrough series. In this video, I'll be working through the list ops exercise from the Exorcism.io Ruby track. So for this exercise, we simply need to implement basic list operations. So things like length, map, reduce, and we're going to pretend that those don't exist in Ruby. And we're going to implement our own versions of those. And they want us, of course, to do it without using any existing functions. So we're not going to, simply alias the built-in functionality. And I'm going to take that as close to the extreme as I can, where I don't even want to use. I'm going to pretend that I'm implementing length, that there is no count or length on array at all. And I don't even want to use any built-in functionality that uses that built-in Ruby count internally. So I'll see how close I can get to that. And there's one spot where I think I want to cheat it actually on refactoring, but we will see. All right, let me pull this down and get started. Remove that default file, and I want to pull in my rake file so I can run my tests. Start a new tmux session. And let's take a look at the tests here. Okay, we have a listops.rb file that I just deleted, and it has some class level method. Arrays, which is test count empty. Okay, so instead of count or length, they're calling it arrays, which is interesting name. But so it'll take an array and it will return an integer. Okay. What else do we have? Reverser will reverse an array. Concatter. It has to be somewhat optimized because we're going to have gigantic examples here, it looks like. So reverse, concat, map. Filter, a sum reducer, and a factorial reducer. All right, let me open up my test running pane and run the tests. They're going to fail, of course, because I deleted that listops.rb file. And so the first thing I'll need to do is create that file. Let me reverse the panes here. And now I need to initialize my class, listops. The next failure is going to be because I don't have a class level method, arrays. So let me do that. And then next, my arrays method is not accepting any arguments, but we're passing one. So I've got a wrong number of arguments. Error there. Let me take a list. And I'm going to go ahead and just jump ahead and return 0, a hard-coded result of 0. All right, let's move on to the second test here. It's going to fail because in this case, we should be returning 5, but we're returning that hard-coded result. So I need some way of counting the number of items in this array and returning that. Now, of course, what they told us not to do is that. That's cheating, right? Because we're pretending that Ruby does not have a default implementation. We want to do our own, and so what we want to do is simply, I think, walk the array and count. So let's see, if we default it to 0, that first one's going to pass, the second one's going to fail again. And then what we can do is, let's see, actually, we want to loop and just walk our array. And I'm going to fetch the item at count. and then increment count. The reason I'm going to use fetch here, let me just start out by indexing into the array. This is going to run forever the way it is. What I can't do is anything like this, like you would think in this kind of array, because length doesn't exist. I don't have it. So what can I do? Well, I can just keep going until I run off the end of the array. But the reason why I want to use fetch here, let me show you here in array. Where is fetch? Is that if there's no element at the index, if the index is out of bounds, out of the array bounds, it will throw an index error. Fetch will throw an index error. Or we can give a default value, or we can give a block. And then what will happen is if we give fetch an index that is outside the bounds of our array, then whatever is inside this block will get executed. And let me show you how I can use that to our advantage here. I can create a block here that will return the current value of count. And so what's going to happen is I'm going to come in here. It's 0. In the first case, the array is empty. So there is no element at position 0. So fetch is going to execute this block and it's going to return count, which will be 0. In the second case, there are 5 elements. So list will fetch element 0 and then increment 1 all the way up to 5 till count is 5. And then the same thing will happen. We're going to try to get the element at position 5. And when we call fetch, that's, that is out of bounds. That's outside of the bounds of our array. And so the block will be executed and it's going to return count. And so this will work. And actually, we don't have to return count at the end there because we are explicitly returning it when we run off the end of the array. And so test count gigantic should work too. And now we're going to use this method, I think, in pretty much every other case here, because we're going to pretend there's no built-in count or length on array. So, okay, the next thing we have to do is reverse an array. This will fail because there is no method, class level method reverser. Let's implement it. Again, we need to accept an argument, and we're not right now. So let's accept list. Let's accept list. And I'm just going to go ahead and return list. And so that's going to make that one pass the first time. But then this will fail because it's backwards. So what I'll do is, let's see, index. I'm going to get an index, and it's going to be equal to arrays list minus 1. So this index will point to the final element in the list. Let me create a new list and then return that down here. And then what I want to do is I want to walk my list from the end all the way down to the beginning and add each element into my new list. So while index is greater than or equal to 0. And then I will, so normally what I would do is I would shovel that element. So list fetch index into the array, and then decrement. Let's decrement index. So that this should work. Oh, new list. Sorry. But I'm not going to do it exactly like that, because if I'm not mistaken, this double left arrow, or what I call shovel method, if I look at the source here, see how it uses this r array underscore len. This is the Ruby array length function in the C code that is underneath this in Ruby. So I don't want to use this. I want to see if I can get away with not using this anywhere, because this is basically the code that underlies count. If I look at count, you know, there's some other checks and things that happen here, but at its heart, you know, you're using that Ruby array length to get at the size of the array. I want to avoid that. So instead of doing this, I want to push the value onto the end of the array, because that does not, at least at this level, use that Ruby array length method. Now, Ruby array cap might, but you know, there's only so far I'm going to go in an exercise like this to adhere to the spirit of the rules. So let's just do this. And I'll use push from here on out in other cases as well. Let's see how that looks with a gigantic reversal. I think it'll be fine. Okay. Concat is next. Concatter. Of course, that'll fail because we don't have concatter. So let me go ahead and define that. So we have two lists here. A new list, and then I'm going to return the new list. That should be enough to make the first one, the empty one, pass. So let's do a normal one. We're going to concat these two arrays. That's, of course, going to fail because we're returning a hard-coded value of an empty list. And what I'm going to do here is I'm going to dupe the first list. And then I want an index of 0. I want a count that's going to give me the total length of list 2 using our arrays method that we created up above. And while index is less than count, and so I want to push list 2. Let's see, I can just use the array, the index accessor, and increment the index. Okay. And this should work fine for gigantic, should have good performance for this kind of operation. Okay, mapper. Same thing. We don't have mapper yet, so we need to define it. Mapper takes a list, and if we look at this, well, here it doesn't. This example doesn't give a block, but this example, the second example does. This is how you normally use map, right? You have a block to execute for each element in your list, and that becomes whatever this block returns becomes the new value at that element, at that same position in the new list that you're returning. But I'm not gonna explicitly capture it here because you don't have to do that in Ruby. Instead, I'm gonna create, let's see, a new list that's empty, an empty list, and I'm gonna return that at the end. I need an index. I need the count of my list, and I need a loop over it while index is less than count. And what I need to do here is I need to push the result of yielding that the element at the index position in my list, and then increment the list, and then I'm returning new list. So does that make sense? Let me explain this. Well, of course, let's see. I'm doing that for the empty mapper. Let me test it with some real values here to make sure I'm doing this properly. I jumped ahead to implement what I needed for the second task because I understand what map does and how it works. But let me explain this. The yield keyword in Ruby, if you call a method with a block like this example here, where see we have at the end list ops mapper is given this array 1 2 3 4 5, and then inside of these curly braces there is something going on here, right? There's code in here. These pipes with this n means that this block is given a single value, and then it's going to add 1 to that value and return it. And so the yield keyword will call that block with whatever you pass yield. So I'm taking the element in the list at the position index and pass it into this block. And so it'll have 1 added to it. And then I'm taking the result of that and pushing it onto the new list. And so each element, you'll get this new array that each element is 1 larger than the original array. That's how that works. Gigantic should work. And again, the way we're doing this, it should be fairly performant. We're simply traversing our list. All right, next is filterer. So what filter usually does is this also takes a block, and if that block returns true, then that element gets included in the new array. If that block returns false, then that element does not get included in the new array. So you're filtering your list. Of course, here I haven't defined method filter, so that fails. So let me go ahead and do that. Filterer. And I'll just go ahead and do some of this boilerplate. That'll pass because it's just an empty array. So this will not pass now. Because I'm just hard coding a value. But what I need to do, I have a list. I've been given a list, and this is a block, right? But it's a short. This is a using this Ruby shortcut syntax, shorthand syntax. This unary ampersand and then a symbol. And so what unary ampersand will do is call toProc on whatever you give it, whatever's to the right. So if you call toProc on symbol, if you look that up, then you'll see that it will convert this into a proc that will take something that you give it, take an element, and call whatever this symbol name, call the method name that on that element. So what it's going to do is it's going to look at each of these and call dot odd a. And this, of course, will return true or false. And we're going to pivot on that inside of a loop. You notice this loop is almost identical in every case. The only outlier we have so far, not counting the arrays method, is, oh yeah, speaking of which, I need to get my index. I need to initialize my index and my count. In fact, let me clean that up a little bit. The only outlier is reverser. Because we're not walking, in the reverser's case, we're not walking the array in forward order, we're walking it backwards. So, okay, yes, so filterer, back to filterer. We are going to push the element. So let me get this. Element is list index. We want to push element if yield element. I think is what we want that to be. Oh, and I'm not incrementing. Cancel that. It's going to run forever. I need to increment my index, or it'll run forever. That loop will never stop. So you see what I'm doing here is similar to mapper. I'm pushing something, right? I'm pushing, but not the results of yield. I'm pushing the element if the block yields true. So whatever I was given here, if it yields true. Okay, gigantic again should be fine and should be fast. Sum reducer. All right, so we're not given a block here. We're just told that our reducer is a sum reducer. So we're just going to add up all the elements and return the result. Of course, this fails because I don't have I don't have a class level method reducer. All right, what have I done? Where did it go? So let me go ahead and define that. Okay, this is not going to return a list. This is going to return an index, or return an integer. And in the first case, it's 0 because there's no elements at all. Oh, and I need to name it properly, sum reducer. And then this test, of course, will fail because I'm returning 0 and it needs to be 55. All right, so I'm going to call result 0 and return result. I need my index and my count. And then loop over my array again, so I don't forget that. And then what I'm going to do is result. I'm going to add list, the element at list, at index. And so that's just going to add each of those, add them each together, each element, and return the sum. Okay. Factorial reducer. So this is going to multiply each element. It's going to be just like what we had, except it's going to do multiplication. So let me back up here to 26. And so the result will start at 1 instead of 0. Of course, I need to set it equal to okay. Normal will fail because we're returning 1. So let me do the same thing. I need my index. I need my count. While index is less than count, result times equal list element at index, and index I will increment. And that should be our factorial reducer. All right, who is still skipped? Here it is. Mapper normal, and that'll pass. Okay, now you might have guessed from all this duplication that, that there's some refactoring in order, and you would be right. We can abstract away all of this duplication, making use of blocks and yielding, just like we did, just like we implemented before. And so what I'm going to do is I'm going to create a private method. And what's interesting is, like, with any of these sorts of things, these can all be implemented using a reduce operation. But I don't want to confuse things with the naming. So there's another name for this. Let me make this a private method. I'm going to call this a fold operation. And folding, like a reducer, it's going to take a list, and it's going to take a default accumulator, and then it's going to take the bulk of what's going on here. So let's see. How do I want to do this? I want to initialize a new list. And I'm going to make this, I think, accumulator.dupe. So whatever we get passed in as our accumulator, that's what I want new list to be. And then I'm going to return new list at the end. No, hang on. I'm not going to call it list because it's not always a list, right? Sometimes it's a number. It's like whatever we get passed in. And all of these index over the array. I'm going to ignore reverser for a minute here. So I want to take the same thing I did everywhere else and get my index, initialize it to 0, arrays of list, and then I'm gonna just simply walk through my list. So while index is less than count, I'm going to increment index. But before I do that, I'm going to yield. Hang on. I'm going to set the accumulator to whatever gets returned from yielding here. And yield is going to be, I'm going to yield the item in the accumulator. Wait a second. The item in the list at index. Okay, does this make sense? So let's look at this again. We're given a default accumulator, which we might want to just default to that. So I don't have to pass it in every time. if it's something different. Most of these cases, it is, I'll tell you what, I'll be explicit at first and then I'll refactor to that. Most of the time it's going to be an empty array. And then I've got a list. And so I duplicate the accumulator so I'm not modifying what I've been passed. I'm actually creating a new one. I'm setting my index to 0, my count to the length of the list. And then I'm just going to walk through my list and hand each element to the block in the calling code. And that block's job is to return whatever the new value of accumulator is. And actually, I need to give it the accumulator and the list. So it will do whatever, it'll put accumulator in whatever state it should be after receiving this element and pass it back. And we'll just keep walking all the way through the list, and then we'll return accumulator. So let me give you a concrete example of this. So some reducer here we'll call fold with list and a 0. And there'll be a block that will be given accumulator and an element. And then really it's just, you look here, you see it's adding whatever's at that index, adding the element to the result, which in this case is the accumulator. So the new value of accumulator is accumulator plus element. Let's see, I might need some parentheses or something. I think, yeah, it's complaining about this syntax error. There we go. And so I can just use this. I can keep doing that. Same thing here, fold. It's going to be a list and an empty array. Has the accumulator and the element. And then we are going to push yield element. And this is where it starts to get a little trippy. Let's see if I did that right. So notice that we have like 2 levels of block execution, blocks being yielded to here. We are calling fold, which will yield the accumulator and the list back to where we are, back to the calling code. Where are you? Here we go. We'll yield those here to our block. And then in turn, mapper will yield the element to the calling code, which is in the test code. And whatever the result is, mapper will push that into the accumulator. And then remember, this entire, this method returns the value of the accumulator at the very end. And so that's what we return. Let's just keep going. Going to fold list with an empty array. And then this, let's see, filter is going to push element if yield elements. So if the outer block, the calling block, returns true, then we will add it to the accumulator. Otherwise, this won't work. All right. Let me explain why this failed. We are only returning a value if the outer block returns true, which means that we're nilling out our accumulator in every other case. So I need to, if yield element, then we're going to return, then we're going to push element. Let's see, I don't want those. Otherwise, we just want to return the accumulator as is. And actually, you know, I don't like that if else statement as much. I think I'm just going to use a ternary here. I need to put parentheses here. Okay. Onto the factorial reducer. Got my list, and my accumulator starts at 1. And then it's going to be accumulator times the element. That's the new value for accumulator. Concatter. So let's see, fold. I'm going to give it list 2. And then my initial value for the accumulator is list 1. And then what I will do, let's see, acc elements. I need to return acc push list element. All right, what else? Okay, that's it. That brings us to reverser. The problem here with reverser, every other case, we're walking the array from 0 to the top. Here we're doing the opposite. We're starting at the end and walking backwards so we can push the element onto the end of the array. Now we can bring this in line if we use the analogous method to push that adds an element to the beginning of the array, and that is called unshift. But according to the rules that I set myself here, there's a problem with unshift. In that, whoops, all right, it's already open. Unshift uses that Ruby array length function. So I can't use it here. If I could, then this code would look like this. And then I would unshift element. So that would be adding it to the beginning. And that'll work beautifully. But it violates the rule I set for myself. Notice this isn't really the rule that they set for us. I could pretend that unshift uses, my arrays, my implementation of arrays here. I don't know. I could, man, it's to do something native that is similar to this. I could do something like this. I could create an array for elements and add the accumulator to the end. The problem is for the gigantic example, this is going to run forever. It's going to run for a long time. I don't actually know how long this will run. I could just let it run and tell you. But look, this is already, this is a long time. I think what I'm going to do for the sake of clean refactoring here is I'm just going to go ahead and unshift and pretend that unshift doesn't use our array length, or I can just have this one method be outside of that refactoring and, simply walk backwards down my list. I don't know which I prefer here. I like it to be parallel to the others, but I'm going to do this because I feel like that's cheating. Let me know which one you would do. There's one more refactoring I want to do, and it's, again, notice that 1, 2. Well, I guess it's only 2 of them. But anyway, two of the 4 methods that use fold here. 1, 2, 3, 4, 5. Two of the wait, is this right? Yeah, 2 of the 5 default to an empty array. So, I'm not going to worry about defaulting this to that. I'm not going to worry about that. I think this is a case where I would, there's just really not enough examples that start with that for me to do that. If I brought reverser into the fold, so to speak, no pun intended, I think I would go ahead and default this to simplify the calling code. I would default this value to an empty array, but because I'm leaving it outside, I'm not going to do it. Yeah. All right. I think this is it. This is what I'm going to submit. Hey, thanks for watching. Thanks for sticking through this far. If you've stuck with me, this was kind of a long one. If you got value out of this, please go ahead and click the like button, and don't forget to subscribe and click the notification bell if you want to know when I've got new content out. All right, have a good one, and I'll see you in the next video.